So I guess for the next section, we're going to
Hello, everyone. Welcome to PyTorch Lightning stream. So in this one, we are going, recently PyTorch Lightning releases 1.6 version. And in this one, we are going to walk through the major changes that we made in 1.6 release and everything we did. And this is going to be a list of streams. We'll start with the basic ones and go through all the major features in separate streams. And this is how it will go. So my name is Rohit. I work as a research engineer at PyTorch Lightning, and I'm going to be your host today. So let me share my screen. Awesome. So let's start with some conversation. Like, how many of you have started using 1.6, and like which versions were you using before that? You can comment and like you can check. Awesome. So let's start with the basic. Okay, there's some issue with the Twitch stream. Give me one sec. Oh, awesome. Someone is able to hear it. That means there's an issue with the user. Okay, let's get started. Let's start with like which versions you are using currently in your projects for PyTorch Lightning, and have you guys tried 1.6? How do you feel? You can comment, and let's roll. Awesome. So yeah, on recent Tuesday, we released 1.6 release, and the major highlights are present in the release section. You can check them out yourself, or I'll walk through quickly on the major changes that we made. And then we'll pick one topic, and we have a guest today who will introduce that topic in depth. And in the end, we'll take all the questions. Also, we can take questions in between. So if you have anything, just post it, and we'll answer it right away. So the best thing in this release is that we had a lot of new contributors. Like this is the first time we saw that we had around, sorry, 60 plus new contributors. So that is pretty great. And we have a lot of contributors that are coming up. Sorry, one sec. Okay, one sec. Okay, let me open it again. Awesome. Sorry for the disturbance. Yeah, so major changes we have is that we introduced Bagua strategy. This is similar to DeepSpeed, but a little better. And we use the enhancement with the strategy API we integrated in with our new strategy API that we are going to discuss today. And next thing is we did some improvements over Lightning CLI, and we stabilized our accelerator strategy in plugins API. And next thing is some Slurm requeuing is improved. Fault tolerance training is improved. We are going to talk about it more in one of the streams after some time. We made some improvements in data loading and loop customizations. Introduce some new hooks that can help you use external packages. Like for this one, you can now use stem schedulers easily with PyTorch Lightning. We have new stateful API, some new properties. So yeah, that's all. That's all we made. Plus a lot of bug fixes, of course. So for this one, we are going to deep dive into the stability for accelerator strategy and plugins API. And today we have Adrian, who will walk you through everything that happened. So let us welcome him. Hi, Adrian.
Hello, can you hear me?
Yes.
Perfect. Hi. Yeah, hi, I'm Adrian from the PyTorch Lightning team. And today I want to talk about accelerators. So this is the part of this is the section here in the release notes. And in this release, we are announcing that the accelerator and strategy and plugin API is stable. What does that mean? It means that we have fleshed out the internals of PyTorch Lightning, grouping all the accelerators and plugins into a nice API that we declare now as stable, which means that anybody who wants to extend PyTorch Lightning with new accelerators, strategies, or plugins can now rely on this new API and publish their new extensions. The accelerators and strategies have long been a core part of PyTorch Lightning, but they were never really exposed in a way that you can extend. Over time, we in the core added a lot new strategies, but you couldn't really extend them in a way that doesn't break in the next version. So previously, these were called training type plugins, precision plugins, and what you could do is pass them into the trainer. So today I want to walk you through the changes that happened from previous versions to the new Lightning 1.6 version, and kind of walk you through what kind of changes you need to make to your code to access them. So in Lightning 1.5, we introduced a new syntax for choosing accelerators. So what we had in the beginning is just the simple flag, GPUs equals 2, or we have GPUs equals 2, or we have, what else do we have? We have IPUs that you can select. Or we had another flag if we wanted to run on CPU. We had num processes. My computer is a bit slow here. I don't know why. And so basically, every time we add a new accelerator support to Lightning, what we have to do is we have to do a new flag here. But that doesn't really scale very well because people can now not just extend the trainer and add a new flag. If they want to have an experimental accelerator and use it, it's not so easy. Also, the number of trainer flags increases. It's hard to discover new features. And so we made the decision to go with a new syntax, which is just the accelerator as a string input plus devices. And now devices is generic. general to whatever accelerator you're using. This new syntax is also great because it allows you to define devices equals auto, and then choose whatever accelerator you want. Now, auto can just select whatever the number of devices is you have on your hardware that you're running this PyTorch code, and just select the maximum number of devices or whatever the accelerator needs. And it allows us also to define accelerator equals auto, which means whatever hardware you're running on, the trainer can detect what hardware is available, how many devices are available, and this is basically now the default if you just initialize the trainer. This wasn't really possible before because we would have to add actually like an auto devices flag, which would be another flag that we would have to make compatible with all the accelerator, and it's hard to discover and so on. So this is the new simplified API for selecting one, the accelerator, and second, the devices. And by default, it is auto and selects whatever is available on your hardware. Now, this is not really news. Just in case you are running an old version of Lightning and you would like to upgrade, you will be encouraged to use this new syntax. The old one still works, so you can still use GPUs if you want. You can still use TPU cores and all that. It still works, but in the future, this will be deprecated, and we are slowly migrating to this new API. And so this was introduced in 1.5, and now in 1.6, we're basically following through with the strategies. So what we have is now an extra strategy flag where you can choose the accelerator. So previously, the accelerator was not just the device, the hardware that you were using, but also you had the option to choose the strategy, so the way multiprocessing works. So we have a couple of choices here. We have the DDP, distributed data parallel, but we also have DP, we have horovod, and all these options that you can select. We have deep speed. But what changes now in 1.5 and in 1.6 is the accelerator here is no longer the argument you use to pass in these strategies. So the new way, I'm going to revert this. The new way is to specify the strategy argument and pass in the name here. So the names stay the same. If you were using DDP before, you write DDP. If you were using DP before, you use DP here. If you were using horovod, you just keep it at horovod, and so on. So that's great. Now, if you want to switch from say GPU to CPU or another hardware, you just change this flag. If you want to change the number of devices you run on, you use this flag here. And if you want to benefit from multi GPU training and multi-node training, you can choose the strategy you want to use. You can choose the strategy here that yields the best performance and throughput for your multi GPU training. Now, for the advanced users who want to customize these internals further, we exposed previously a plugin API under PyTorch Lightning.plugins. And what you could do is you could import these plugins that you previously specified as strings. You can import them as objects. And what you did is you added the plugins flag here and passed the instance of the plugin in here. So for example, if you wanted to use find unused parameters, and your model doesn't have any unused parameters when you do the backward, then you can set this to false. And this gives you a little speed up. So So this was the previous way of specifying that in PyTorch Lightning. In Lightning 1.6, this is deprecated, and the DDP plugins, the training type plugins, now become strategies. So they are renamed into strategies. And so what you have to do is you have to replace DDP plugin with DDP strategy. In fact, if we go in here and look at the code base, the DDP plugin now just inherits from strategy and prints a deprecation warning. So in summary, if you have a custom strategy or want to change the parameters of the strategy or previously plugin, you use the strategy flag here and you pass in the strategy instance. So I see a question in the chat. Let me go over to the chat section. The question was, hi, is the accelerator auto also possible with strategy equals DDP? So yeah, so both options are possible if the accelerator you're running on, if the hardware you're running on supports DDP. So if you, let's say, so where's the example? Here we have the example. So if you're asking if accelerator is auto, and I select strategy DDP here, is that compatible? Does that work? Yes, it works. So auto, if you are on a notebook that doesn't have a GPU, auto will select CPU, and DDP, since DDP supports running on CPU and GPU and all these devices, will just work. Because the strategy doesn't really care about the hardware, most of it. What it cares about is just the communication between the devices, and all the device hardware abstraction is in the accelerator. So yes, this works. If you're on a GPU machine, auto will select the GPU and you can use DDP on there. Great. So let me go to the next section. So I mentioned that the DDP plugins were basically renamed to strategies. So that's one big change that we made, but that's just the renaming, right? So it's deprecated, it still works, and if you want to use the new API, you rename your class and all is good. A bigger change is that internally, the accelerators used to be the top level manager of everything. So the accelerator previously managed the training type plugins, so DDP, DP, Deep Speed, and all these plugins. And it also managed the precision. So we had the accelerator. Inside of the accelerator was the training type plugin, and inside of the accelerator was the precision plugin. And as we were adding more and more strategies and accelerator, we realized that this is not really the best construct. And we decided to invert this relationship. So in 1.6, the training plugins are now called strategies, but they are also now at the top level. So accelerators are now inside of the strategies, and precision type plugins are also inside the strategy. So the strategy now manages or owns the accelerator, it owns the precision, and whenever the strategy needs to do any hardware-specific operations, it calls into the accelerator. And whenever it needs to do precision-specific operation, it calls into the precision plugins. So this is a major change, and it doesn't really affect anybody that is just using Lightning and not caring about custom strategies. But if you are a user who likes to customize strategies and implement experimental strategies, use third-party libraries or new accelerators, then that change is important for you. So I see there is another question. So on Slurm cluster, it would also select the max GPUs. Good question. That's if... So on Slurm, it's a bit different because usually on Slurm, you have a separate launching script where you, or a configuration where you select specifically the number of nodes that you request from Slurm, the number of nodes and the number of GPUs. So this is an information that you need to give to Slurm, the cluster manager. Then the cluster manager queues you and gives you eventually the resources. But then inside of that process, Lightning runs, and you can technically choose accelerator auto, and you can technically choose devices equals auto if you want. But you just need to be careful that like the configuration for Slurm is compatible with the training you're running. But yes, in theory, if you do accelerator equals auto and you ask Slurm to give you GPUs, then the trainer will use the GPUs, yes. Good question, yes, interesting. Let me... It's like, okay. So yeah, so I was talking about the composition of internals. So in summary, here is what the current stable composition looks like. So strategies are at the top level. So this is this part here. And inside we have the accelerator, we have the precision, and then we have other optional plugins, for example, the cluster environment. So the accelerator here is abstracting everything that is related to hardware. So we have a CPU accelerator, we have a GPU accelerator, TPU, IPU, and the newest one that joined the family here is HPU from Habana. Please check it out in the release note. You can try it out and read in the docs. But yeah, like in the future, when we will add new support for new accelerators, this will just be another accelerator here, and it stays completely independent of the strategy. And also the precision here is inside of the strategy now. So, so this is how the strategy from now on will be composed. And of course, the strategy is used internally in the trainer by the loops. So whenever the loops need to do a computation on the device or with multiple devices, it calls into the strategy, which will then decide if it needs to call into the accelerator or the precision or the cluster environment and so on. So why am I talking about this is, again, it's because this is for users who want to build experimental features based on distributed training, optimizing distributed training, new experimental accelerators, so that you basically don't get blocked by Lightning. You don't need to wait for Lightning to add this new feature. You can just experiment with it and add support for it. Basically extend the trainer as you desire. So if you already have, there's a new question. Do I need to specify the cluster environment somewhere? Yes, you can. By default, the trainer will try to detect the environment automatically. So I can show you this in an example. So here at the bottom, it's out of the way. So by default, the trainer will just detect whatever cluster environment you are in. So if you're running on Slurm, the trainer will detect that you're running on Slurm, and it will select the Slurm cluster environment. If you want to specify your own cluster environment, and that is not mandatory, it's just optional, what you can do is you can do plugins, and you give it a list of multiple plugins. But if you just want to select a cluster environment, you either import it from Lightning, so from PyTorch Lightning.plugins.environments, and then you choose one. Let's say the Bagua environment. The Bagua environment is recently added. You can then just pass it in here, and now the trainer will use that. But I just said that the plugins are inside of the strategy. So what does that mean? It means that whatever plugin you add here, it will just be replaced inside of the strategy. So whatever strategy you end up using here, the cluster environment you choose here will be replaced inside or set inside. Okay. Of course, you can also implement your own cluster environment. And for this, you import the base class. So from here, import the base cluster environment here. And then what you do is you define my cluster environment. You inherit from this class. And then what you need to do is you need to implement all these abstract methods, right? And then you can implement your custom one, and you just pass it in exactly the same way. So my cluster environment here. And then the strategy will use that. So I hope, so this was a long answer. I hope this answers your question. This is really for advanced users who run on a custom cluster that we don't support. Maybe it's, one that only your university uses, or maybe it's a custom one, it's an experimental one, and then you want to be able to use that environment. You can learn more about cluster environments in our docs, which I will show you really quick. So if you want to learn about them, you go to optional extensions here on the side, and you click on plugins, and there you can learn more about the cluster environments. They should be listed here at the bottom, and the ones that we support, and how you can write your own. Okay, so that was just for answering the questions. Back to my notes. So that was the cluster environment. But what if we want to build a custom accelerator? So previously in Lightning 1.5 or lower, what you did is you inherited from the base accelerator class. So you import PyTorch Lightning.accelerators accelerator here. This is the base class. And what you did is you implemented some methods that are required, and you wrap your models. You do whatever you want to do in that custom accelerator. You use the third-party libraries and so on to connect to your device and so on. Then what you do is maybe you have a custom plugin. So you extend one of our own plugins, you customize it, you override some methods and so on. Or maybe you even have like a custom precision plugin. So you subclass our precision plugin. You oops, this is the wrong method here, but you implement some of the built-in methods. The hooks. You override some hooks. And then what you did before is you instantiate the custom plugin, you instantiate the precision plugin, the accelerator, and here is what you did before is you had the DDP plugin inside of the accelerator. So you said training type plugin equals my custom plugin, precision plugin, my custom precision plugin, and then once you have the accelerator, you pass it into the trainer. This is how you do it in Lightning 1.5 or lower, okay? In Lightning 1.6, as I explained, the relationship of accelerators and plugins has changed. They are inverted. The composition is different. So you no longer pass the plugins into the accelerator. So, so the new way, again, we have strategies, not plugins. So we need to inherit from DDP strategy, not DDP plugin. Once we have that, we construct our accelerator. We instantiate our precision plugin if we have one, if we want one. And then it's the strategy that takes in the accelerator and the precision plugin. So this is a big breaking change, but again, only this affects only sort of expert users who want to customize the trainer and the plugins and the strategies and so on. And instead of passing it into the accelerator flag here in the trainer, now what you do is you take the strategy argument and you pass the strategy in there. So again, if you have any questions, just ask away. I know this can look a little bit complicated because it's really for the more advanced users. Another thing is that the accelerator is now fully abstract, which means that previously you could just subclass it and it wasn't really an abstract class. You had some hooks that you can override, but you didn't really know what is required and what is not. So now the accelerator is actually an abstract class. And here are all the methods that you would have to override if you make a custom one. So we have setup, we have device stats, which is optional. So the default, it would return an empty dictionary. The accelerator defines how devices are parsed. So if you pass in devices into the trainer, now the accelerator can decide how to parse them, maybe have some error messages related to that when you pass in invalid, indices or whatever. It also has, and this is important, it has the auto device count. So depending on which accelerator you run, on which hardware you run, you can now define how do we determine the number of devices we use when we pass in auto. So whenever you do trainer devices equals auto and accelerator my custom accelerator here, whenever you do that, now it's up to this custom accelerator to decide what happens when devices is auto. How many devices do I get? So this is implemented in this hook. And then it allows you to define when an accelerator is available. So you check whether the hardware is available. And if it returns true, then you will pick this accelerator automatically. Okay. And this last part is only important when it comes to accelerator registries. So in Lightning 1.6, we have this concept of registries, and you can register your custom accelerator as an option in the trainer without passing in the custom class explicitly into the trainer. So this enables you to select, first of all, accelerator auto, right? It also allows you to pass in just the name that you registered. And this now makes it possible for you to pass this in via the command line. So if you, in the terminal, let's say you did Python train.py, and now if you're using just regular argument parser, you may have something like accelerator equals, and then the built-in types are CPU, GPU, but now you can also register your own accelerator, and now this string here becomes available in the command line. So you can now just select whatever string you require here. Or you can pass in auto, and if you are on the hardware your accelerator belongs to, then it will basically run into this method here and select it. If it's available, auto will select this new accelerator. So that's pretty cool. The same is basically true for the strategies. So you can also have, there's also the strategy registry. So the strategy registry works exactly the same. So it's called strategy registry. And you can register my strategy, my what's it called, custom DVP, I don't know. And then what you do here is you can pass in strategy equals my strategy. Again, also in the CLI, you would do minus strategy equals my strategy. And if you're using the Lightning CLI, of course, the syntax is as always trainer.strategy and trainer.accelerator, or whatever trainer argument you have. Great. Are there any questions? Doesn't look like. So these are the major changes in PyTorch Lightning 1.6. I'm going to summarize again. So if you have a trainer that uses XPUs equals some number, replace it with accelerator equals the type, and then devices equals the count. So here we would write accelerator equals CPU and devices, well, 5 is not really valid, but 8. Okay, so this is how you upgrade to 1.6. Then if you have accelerator equals name, and the name was a strategy or a training type plugin, replace it with strategy equals name. So strategy equals this, or whatever you have here, your favorite strategy. Or if you want to try to replace it with auto. And if you had custom plugins, or you were using plugins that had options and you passed in options into these plugins, now change the import from PyTorch Lightning plugins to PyTorch Lightning strategies, and change the name from plugin to strategy. And in your trainer, pass in the new one here, and don't pass it into plugins, pass it into strategy. And that's basically it. You can keep using the old plugins the same way. When you rename them, they are the same. They have the same arguments, and most of the options stay exactly the same. If something changed for a strategy, it's documented in the changelog. So if you're curious, you can go to the release notes, and at the bottom, there's the full changelog. Yeah, here. It's not loading, excuse me. Yeah, here. There's a changelog, what's added, what's changed, and what's deprecated, what's removed, and of course also the bug fixes here. Yeah, could something like auto sharding be possible? So I'm not sure what you mean by this. Could something like auto sharding be possible? You mean like sharding the model by default without you having to wrap your model with, or what exactly do you mean? Can you specify, can you clarify in the chat, please, if you don't mind? So yeah, so the way I can tell you the way you, I mean, okay, so I mean distributing the parts of the model based on how many GPUs. I mean, that basically happens. So yeah, so we have the plugins for that. So we have so we have multiple ones. So we have strategy. We have FS. So we have sharded, which shards the optimizer states, but we also have FSDP. I believe this is the name here, which shards the model. Yes. And if you, I'm not sure if what your question was, but you can choose the devices here, and your model will be sharded for this number of devices. And you can also put auto, and then it will do that. Does that answer your question? Yep. Awesome. I'll just wait a little bit longer here, just in case more questions pop up. I can show again the docs. So the docs have updated a little bit. So if you go to the PyTorch Lightning docs, you see latest here in the URL. You are on the latest version. Just to make sure, you can also down here select the version of the docs you want to look at. So make sure you are on latest or stable here. And then you're looking at the 1.6 docs. And then on the side here, if you're curious about accelerators and plugins and strategies, we have here this section, optional extensions. We have accelerators, which shows you all the accelerators we support, especially the new HPU accelerator here that we introduced. I encourage you to check that out. Then you have the plugins here, which now no longer include, as I said, what is now named strategies. So these plugins are now just the precision plugins, the checkpoint IO plugins, or the cluster environments that I talked about. And what was previously known as the training plugins are now called strategies, and they have a separate section here on the left-hand side, strategies. And here you can learn about all the different strategies that we support and how you can create a custom strategy, as I explained. What's also nice to know is, that's not really new, but it's a recommendation. It's this section here, best practices, especially speed up model training. This is useful when you want to use accelerators and strategies and plugins. Here are some tips how you can speed up your training. As things like things to avoid here with caching, or I was looking for another option, which is GPU training, speed up tips for GPU training. There are advanced GPU optimized there's the section for model parallel training using fair scale and deep speed. And then there is, so I'm looking for, I was looking at the link, sorry. I can't find it right now, but anyway. Awesome, that's it from me. If there are no further questions, I give it back to Rohit. Rohit,
Yep.
what's up?
Thanks. Yeah, doing good. Awesome. That was great. So on top of that, now strategies accelerators are out of beta. Now we recommend users to come up with their own strategies or their own accelerators, and if they like to integrate that in PyTorch Lightning, feel free to open issues and ping us. We'll be more than happy to help you and integrate more and more so that just to grow the ecosystem of Lightning. And if you guys have any questions, we are here for another 2 minutes. Feel free to ask anything. In the meantime, like we can discuss like which versions you are using right now for PyTorch Lightning and which versions you used to use. So let's engage a little.
Yeah, is anybody here upgrading from a very, very old version or plans to upgrade or is afraid to upgrade, like from 1.1 or older? Let us know if you run into troubles.
So looks like we don't have any more questions. Let's end the stream here, and we'll meet next Friday.
Yeah, what's the next stream, Rob? What is the topic of the next stream?
Yeah, it's about Bagua integration. So I've shared the link for it for the PR in the chat. You can check out the PR, and this will be discussed in depth next week. And this is pretty new. So you'll learn how the stability of strategies help integrating Bagua easily for us. So yeah, let's wait for next stream and learn about Bagua integration.
Awesome. Thank you so much. And goodbye. Have a good afternoon. See you soon.
Have a good weekend, everyone.